All right, welcome back everyone. Here's the final example in this final lesson in Unit 1 in Physics 30. You have a stationary grenade which has a mass of 1.2 kilograms and it explodes into 3 pieces. So somebody has pulled the pin on this grenade, put it on the ground and run. Because it's not moving to begin with. Or maybe they didn't put it on the ground, maybe they dropped it and it fell on the ground. So we have that 1.2 kilogram, quote, piece, which is a grenade, sitting there to begin with, not moving. And by the way, that tells us that the momentum before is 0 because the grenade is not moving. What that tells us is the x component of the entire system before is 0, and the x component of the entire system, and the y component of the entire system before is 0. There's no momentum before. What we're told in this question is information about the 0.5 kilogram piece. And if I take 0.5 kilograms and I multiply by its speed of 3 meters per second, that's where this number at the bottom of the screen is coming from. 1.5 newton seconds, and it is north. We also are told there's a 0.6 kilogram piece that's moving at 4 meters per second. If I take the 0.6 kilograms and I multiply by 4 meters per second, I'm going to get the number at the bottom of the screen in that column, 2.4 newton seconds, and it's moving at 45 degrees south of east. The idea here now, just like the previous example when we used components, question 2b, is that we take this momentum. We take this momentum and we rewrite it as an x and a y component separated from each other. Well, that's pretty straightforward. Because all of this momentum is north, that means the y component before is 1.5 newton seconds north. Because the entire momentum is north, that means the x component is 0. When we take a look at this 0.6 kilogram piece, we need to calculate this component and this component. When I look at this triangle, this is the opposite side, so I can write sine of 45 degrees equals opposite over hypotenuse of 2.4. It's a pretty basic run-of-the-mill calculation for us to calculate what that component is using that little trig equation in the bottom right side of the screen. Just make sure I am in degrees. It's going to be 2.4 sine 45. So that 1.697 is the opposite side, and we can write 1.697 newton seconds south for the vertical component. When you take a look at the little mini vector diagram at the bottom of the screen, that vector is south and east, so the vertical component is south. Contrary to how poorly I drew that 45-degree angle, at 45 degrees, both legs of that triangle are equal. So if you do the same thing with cosine to find the adjacent side, what you will discover is you also get 1.697 newton seconds, but this is east. And of course, we don't know what this is and what this is. But let me get to a different color here, sorry. We don't know what either of these are. But what we do know is that when I add up this, this, and this, I have to get nothing because that's the total y before. When we add up this, this, and this, we have to get 0. So I'll rewrite this in a second somewhere else, but essentially this 0 on the left has to equal this 0 plus 1.69 plus this unknown number, which I'll call x. Similarly, we have to add up the greens. So I want to be very careful when we write this out. Here's the x. We're going to have 0 before equals 0 plus 1.697 plus x. And that's going to lead us to x, which is going to be, all we have to do is subtract 1.697 from both sides. And we get that for a horizontal component. For the y, and this is where we have to be careful, we have 0 equals 1.5 plus negative 1.697 plus our y, which we're trying to find. And the reason why it's negative 1.697 is because that 1.697 is south. So when I solve this y equation, I end up with 0 equals 1.5 plus negative 1.697 is negative 0.197, and I just want to double check that. I know it's not that late in the day, but I've been working all day and my brain is just a little bit tired right now. So let me double check that. That's right, 0.197. So now I have to solve this equation. I have my plus y, so I add 0.197 to both sides, and I end up with y equals positive 0.197 Newton seconds. This negative here means west. This positive here means north. And these two are for the third piece. And I never really addressed this, but the third piece has a mass of 0.1 kilograms because the three pieces have to add to give 1.2 kilograms. So now all we have to do is draw that in a vector diagram, which conveniently from the last time I taught this is down here at the bottom of the screen. So we have negative 1.697 Newton seconds for the x, which is 1.697 Newton seconds west. We have positive 0.197 Newton seconds north. This diagram I drew is really poor because it's not even remotely drawn to scale, but the advantage of doing it with components and doing it mathematically is it doesn't have to be to scale properly. So all we need to do now is find this angle and the hypotenuse. Well, there's one more little thing. But let's find the hypotenuse first. Let's take 0.197 squared plus 1.697 squared, and then take the square root. Common mistake would be to forget to take the square root. And I get this for a hypotenuse. Let's find the angle right now. I need to take the inverse tangent of opposite divided by adjacent. So it's a paltry 6.6 degrees. We do have to remember that we're not after the momentum. Let me write down what we've got so far. We've got the momentum of the third piece. is 1.7 Newton seconds at an angle of 6.6 degrees. Looking at the diagram above, we can see it's north of west. We were asked for the speed or velocity, so we have to use magnitude of momentum equals mass times magnitude of velocity. In other words, divide that 1.7 by the mass and we will get the speed. Here's our momentum divided by the mass of 0.1. So we get 17 meters per second for a velocity with that angle. And that's it for the lesson and the unit. I hope that made sense. As I've said a couple times, I think in this video or the last video, it's been a very long day and I'm kind of tired right now, but I hope that made sense. I think it went okay. We'll talk to you next time. Take care.